Hello, good afternoon. Sorry, and welcome everyone. I think there are those who probably have forgotten that this exists because the SMO feels pretty over. It's always true for the day that we go through open. Right, so it feels that every time when I go through the SMO open, it's the most amount of effort for the least amount of viewers and the least amount of people. And I guess that's kind of true for taking the SMO open itself, right? For if you're in JC, you're taking the SMO open when hardly anyone else is doing the SMO. Everyone is preparing for promos, prelims, or A-levels at various points of the year. So we're kind of in the same boat, but I think it's just genuinely some people have forgotten. And so we will just chat a bit and wait a few minutes before we get started with the problems proper. The good news is that this year's questions are not so hard for the SMO Open in some sense. This year's Open is not so hard in some sense. So if you are doing the SMO Open and you open the paper, it doesn't look as scary as usual. We're going to talk a bit more about the actual difficulty, but I would kind of summarize it as it doesn't look so hard, and also the topics are a bit more friendly. What else do I want to say? I guess just talk about cutoffs and all again, since everyone is going to ask about cutoffs, and I will look back to this again later, but right off the top, right? Now, SMO Open has the least participation rate from junior, senior to open. You're talking about usually around 2,000 participants. It's still about 100 qualifiers for round 2. So this is now roughly about 5%. For no section is it true that it's 10%, but it is at least a little bit better than the SMO junior and senior percentage-wise. Now you can think of it in terms of like, who are these 2,000? On one hand, it would mostly include only those who are interested to still do Olympiads if you're talking about the JC students. So then that's like quite a strong group of students in terms of sampling. On the other hand, it also means that like if you are the JC student, you are competing against not a lot, but a significant number of younger students who have a different set of knowledge from you. So if you are Sec 1 to Sec 4, Year 1 to Year 4 doing the SMO Open, most likely you are doing it because you have Olympiad knowledge, but you may not have all the content knowledge, such as like, okay, so when we say the word hard, right, there is the content knowledge and there is the Olympiad knowledge. Now, content knowledge is stuff like calculus, vectors, complex numbers, and then just random algebraic stuff. So random algebraic stuff means all the like JC-ish algebra things, whether it be to do with inequalities, to do with functions, to do with trigo, whatever. So this is content knowledge. And then your Olympiad knowledge, which is something that is not part of JC, right? You have of course got all your number theory things, you have all your combi stuff. JC only really has P and C in the statistics section, everything else there's no combi. There's also no geom in JC to all intents and purposes. So this is the dynamic. Now if you are a Year 1 to 4 student, Sec 1 to 4 student, it is a high chance that this is what you consider to be hard. If you are a JC student with less Olympiad experience, then this is what you consider to be hard. So it really depends on who you are, and that will inform whether you found it to be difficult or not. I feel that for this paper as a whole, objectively it is quite easy to make progress. So you don't look at it and have like everything looks impossibly unapproachable. That's happened before for SMO Open. Now, because of that, I don't think the cutoffs for the, let's say, honorable mention and a bronze are going to be as low as in the usual years. But the round 2 cutoff can never really go that high. Can never really go that high because for round 2, there are always hard questions. Sorry, not round 2. For round 1, there are always some hard questions such that the scores cannot really shoot that high. So if you're asking my initial guess of what a round 2 cutoff is, I would guess somewhere about 14. This is my initial guess. And for, like, let's say silver, bronze, and honorable mention, I think it could go something like 2-point margins. This is my guess because I feel that there are at least 8 questions which a significant percentage of participants can do. Right? A significant percentage of participants can do either because you have the content knowledge from being a JC student, or you have the Olympiad knowledge from being a past or a semi-experienced Olympiad participant. So this is what I'm going to open up with by talking about this paper. I feel that if you are going to the SMO Open thinking, I just hope I can do a few questions, you will find it quite easy because there are at least like 5 questions, let's say, that feel very friendly. If you're hoping to, let's say, get a really high score of like above 15, then you may not find that like beyond that 15 point is very easy to make progress. As with this, a lot of other papers, I'm going to try to give as many approaches as I can. So if there's something that can either be done in the Olympiad way or the non-Olympiad way, I will try to share that. In other words, I want to highlight that for many of these questions, everybody has a fair shot at them. And it starts with question 1, which is pretty much the same as a junior question that we saw 2 days ago in the stream, and actually 2 days ago if you took SMO Junior as well, right? The SMO Junior question from this year was, this was the junior question. This is basically the same as that. I hope there's at least one person that happened to watch my junior stream did not know how to do such a question, and then based on that now you do know how to solve this question. Then I have done one surprisingly useful thing from the SMO Junior review. Now I guess for the SMO Open I'm going to explain it slightly differently, but the starting is still recognizing what SK is. Right? SK is K times K plus 1 over 2, and therefore of course your sum that you want from S1 to S20 is going to be this thing here. Now in the SMO Junior stream I mentioned 2 methods. I'm going to mention 2 methods again, but a different 2 methods. One method is the same, one method is different. I'm also going to write it a little bit differently because if I'm doing this as a SMO Open question, I assume that everyone's comfortable with your sigma notation. So let's go in this way. Now it is useful to write in sigma notation sometimes because it explicitly forces you to recognize what the expression is, and also explicitly gives you a chance of figuring out what to write. So if you have n plus 1 and you expanded it to n squared plus n, then you can just split it into your sum of squares and your sum. Obviously this sum of 1 to 20, if we can know what is S20, this is S20. The sum of squares, let's just give everyone the identity again. So sum from 1 squared to k squared is k plus 1, 2k plus 1 over 6. This is something that you probably should remember. So just compute. And numerical answer is 1540. That's option 1. Option number 2, I will mention the hockey stick identity, because that is what this S case also are. Right? They are all just something choose 2 by definition. And so our sum can also be written as 2 choose 2 plus 3 choose 2 all the way to 21 choose 2. And now I'll first say what the hockey stick identity tells you. It just tells you that this is equal to 22 choose 3, which would immediately give you your answer. Same numerical answer. The second thing which I will say is just to explain what is the hockey stick identity in general. The hockey stick identity is called the hockey stick identity because of your Pascal's triangle, which I presume that many of you have seen long ago, but maybe it is more recent that you are made aware that Pascal's triangle is just filled with these true stuff, NCRs / binomial coefficients. Now, the hockey stick identity basically is called the hockey stick identity because it looks like a hockey stick. It means that if you just go down one diagonal, the sum of the stuff is going to be the thing below. Right? So if I wrote one more row to give one more example. So another example of your hockey stick would be that if I went down this way, 1, 4, 10, 20, 35 should sum up to 70 below. So this is the hockey stick identity, and if you look at what 2 choose 2, 3 choose 2, all the way to 21 choose 2 would look like, it would look like the diagonal that's in between the two I've highlighted. It just goes down here and then eventually it will come down. So this is the hockey stick identity, and it is going to be if you write it out in truth form, this is the general statement. Now, it's nice that we linger on this true stuff a little bit, because the second question is again on this true stuff. So very convenient. We are adding up. Let's write out what it looks like. 1 times 64 choose 1, 2 times 64 choose 2, 3 times 64 choose 3, up till 64 times 64 choose 64. One of the funny things about the SMO Open is that every time they choose to define some stuff, and to be honest, if you just are seeing for the first time what n truths are is, I think you're not going to solve the question, right? If you have never seen that before, you have no chance. And if you've seen that before, why are they defining in the question? But this is one of the weird habits of the SMO Open. They want to claim that it's approachable, so they define everything, but really, if you're waiting to read the definition, you have no chance of solving it. I'm going to just pad it a little bit with 0 because I like it to be symmetric. And then once again, I am going to show you 3 different methods to solve this question. Now, method number 1 is something that a lot of you can do. Find a pattern. So a pattern means not keep adding this until you see something, because the pattern will only appear if you're looking at smaller numbers. So you start with, let's say, 1 times 1 choose 1 equals to 1. And then 1 times 2 choose 1 plus 2 times 2 choose 2. This is 2 plus 2 equals to 4. And then basically this is what I'm doing. I just want to find a pattern So for those of you who are taking the SMO Open as a younger student, these are the sort of things you can do. Like maybe there is some formula I don't know, but because I don't know the formula, I can't figure out the formula while sitting down there in the SMO. I can't Google, so I just look for patterns. So 4 choose 2 is 6, times 2 is 12, 3 times 4 is 12 again, and then 4 times 4 choose 4 is 4 again. Now the question asked me for log base 2 of s, so if you see log base 2 of s, it suggests that s is some power of 2, and 64 is a power of 2. So I suspect that it might have something to do with that. I am not sure what yet, so we continue to try one more, because a lot of these seem to be like, this is 2 to the power of 5, for example. So this was 2 squared. The chat box is very quiet, right? When we are doing SMO Open, everyone is very well behaved. Feel free to chat, feel free to also just listen silently, right? This is completely up to you. Okay, so this is 80. Now that's interesting because I see that this is divisible by 5, and of course it is very obvious that it should be divisible by 5 because each of these individually are divisible by 5. But now I'm starting to see what's going on. Right? It's 5 times 16, which is 2 to the 4. And then this one is 3 times 4, which is 2 squared. And now this 32 is 4 times 2 cubed. So the pattern actually is visible. And that would allow me to say that going all the way up to 64, I expect the pattern will be 64 times 2 to the power of 63. That's what I think S should be equal to. Okay, so your answer would be 69. This is if it is by pattern. Now I shall explain where the pattern comes from in 2 different ways. Now remember that in the SMO, whenever you're asked to sum up a whole bunch of things, there should be a good reason why it is nice. And so one of the ways that a sum is nice is, as in question 1, there's a famous formula to do with sum of squares. Another way is that you can pair stuff up. And so I am going to pair stuff up because 0 times 64 through 0 and 64 times 64 through 64, these are the same. These two are equal to each other. So are these, and so on. So the idea is that you're going to end up with 64 of everything. Well, not everything. Everything up to halfway. Except for the middle, which is 64 through 32. So what do I do with this? I can actually sort of rephrase it as, I don't want 64 of this first one, I can just make it 32 of each. Now this would explain it, because the sum is going to be 32 times of the sum of 64 through everything. And it is pretty well known that this is going to be just the power of 2. If you add up all the different choosers, so this is another way you can get the answer. Yeah, now there are lots of ways that we can do this, so I'll just mention one more, which is kind of fun to show how you can get this instantly, and you will then see that you can get more sophisticated stuff than this. I'm going to start off with this. This has allusions to generating functions. This is actually how many of these questions are discovered. Now, if you put in x equals to 1, you're going to actually get this. If you put in x equals to 1, you don't get the thing you want, because you actually need, you kind of want 2 times this, 3 times this, all the way to 64 times this. And so what you can do is to differentiate. So if you differentiate this, this is where a lot of our identities of these weird sorts come from. Now you let x equals to 1, you get your result. Same thing one more time. So every time when I look at this kind of questions as a student, I feel that I must be able to solve it. Now, not that if you didn't solve it, something is wrong with you, but more that, like, I just feel that there must be so many different nice things that could allow me to get it. So whichever one comes to mind is fine, but you have a fairly good chance because so many options are available. Okay, question 3. Question 3 is a fairly short and sweet solution. You must understand when you have identities that are like possible to combine into an expression, and there are stuff where you have just no hope. Now this one, you have no hope of getting to 2024, so you shouldn't go and try to use trigo identities to get to power 2024. This simply requires you to recognize that sine to the 2024 and cosine to the 2024 are between 0 and 1. It's an even power, so it cannot be negative, and so the only way that the difference is 1 is that this is 1 and this is 0. Of course, this is not something you're afraid of rooting. This means sine x is plus or minus 1, whereas cosine x is 0. And since we're going from 0 to 2 pi, when cosine x is 0, sine x is plus or minus 1. So you just grab the two possible times where x gives you a cosine of 0, which is pi over 2 or 3 pi over 2. The larger one is this, and we do not really need a very good estimate of pi to quite safely say that the floor of 3 pi over 2 is equal to 4. Question 4, this is a repeat almost of a question from either 2018 or 2019. The idea being that if you look at it and say, isn't that usually going to be true? Like, if I throw away the absolute value, it is true, right? So, no absolute value, it would be true. So, if x is big, which could be x is more than 3, then you just get x minus 2, x minus 3, and 2x minus 5, if you want to be precise in this. Now, I'm not saying that this is the whole solution set. It is more that I don't care anymore what is the solution set. If I am asked for the number, it is infinitely many. So infinitely many is 99999 in this question. Question 5. Now, when you are taking the SMO open, one of the problems with the SMO open is that you are thinking this is the SMO open. There was a video that I posted before I started putting up my SMO mock papers. The one where the title was something about a redacted title. The moral of the story is for that video is basically that if you don't know where it comes from, sometimes it's good. And many of the questions that you did not solve, it's probably because you gave them too much credit. You're like, oh, this is the SMO open, it can't be that easy. It is that easy very often. Not always, but often enough that if you saw these questions in the SMO senior or in a few of them, even in the SMO junior, you would have solved it. That's the issue. So look at each question with the assumption that it is easy, and if you're like, it is, but it doesn't look easy, can I get rid of the fact that it looks not easy? Immediately when I see this, my thought is that the whole question is just E everywhere. Now, I used to have as a joke for some of my questions, I used to put in very, very long names as like for the word problems that I set for primary school mock papers. Right? So I just use a very, very long name, like let's say for example, a Sri Lankan name that is very long. Now, obviously for anybody, the name doesn't matter, right? We know. But as a primary school kid, maybe you get frightened of a very long name. Now that we're here, same thing. If the whole question just mentions e to the x, then just substitute it away. If the whole question mentions log, substitute it away. If the whole question mentions sine, substitute it away. If the whole question is just working in that realm. Right, so y is greater than or equals to 1 plus 2 over y. You are only looking at positive y's. That's the only thing I take away from exponentials. And then after that, easy enough. Right, quadratic inequality. You throw away the negative. You just get y is greater than or equals to 2. Then after that, the question asks you for ceiling, not floor, ceiling. Now we know that y plus 1 over y gets bigger as y gets bigger. So the minimum is when y equals to 1. When you go away from it, it gets larger. So it attains the minimum at y equals to 2 itself. Yeah, I see comments about like cutoffs again. I'll talk more about cutoffs later, but what I will say for now is just remember that the cutoffs for, let's say, round 2 depend on what is the number of questions that 100 people roughly manage to solve. Not the top 10 people, but not the top 1,000 people. So the easy questions that everyone can solve will of course push up the cutoff, but they push up the cutoff in a way that doesn't bother you very much. You did solve them. And then the hard questions that only solved by a few people also doesn't matter. So things like these, I think a significant number of people can solve. What else affects the cutoff is also whether the questions are designed in a way where you can accidentally get the correct answer, or not. And I believe that many of you have accidentally got the correct answer for question 6, because the question said the sets are disjoint, right? And some of you thought that this just means that I need to make sure that 2x squared plus 2x plus c is not x squared plus 24x plus 2, right? This is what you thought it meant. And so, not for integers x. So some of you thought this and then you just moved it over. And then you say, okay, let me just try 25. And then you say that, okay, this one, no integer solutions. And therefore, you say the answer is 2025. 2025 is correct, but this is the wrong explanation, which will be another thing that can affect cutoffs. You see, like that's the thing about the SMO. Like when you look at the cutoff, it's very hard to guess, because like this is a question that is easy to guess because you may have gotten the wrong understanding of what the question is. Now, the question is not the same x, right? Sets are disjoint. This means that the question is not asking that. The question is actually asking that 2x squared plus 2x plus c is not equal to, not the same x. Let's get why. This is what it is trying to say. This is what it actually is supposed to be. It is still 2025, right? So the thing is that the answer is still 2025, because if you look at 2x squared plus 2x plus 2025 and y squared plus 2024y plus 2, and you consider mod 4. Now, this is always going to be divisible by 4. So this left side would be 1 mod 4. Y squared, a square is 0 or 1 mod 4. This is 0, this is 2, so you basically get 2 or 3 mod 4. So the answer is really that for 2025, the two sets are disjoint, but not in the way that many of you thought of. I'm a bit cruel sometimes when I set my mock papers. When I set my mock papers, I try to make sure that if you misunderstood it, you will be wrong. For the SMO, they don't always do that. So in this case, if you misunderstood it, you will not be wrong. Yeah, but so that means that your answer is really 2025, but for the initial one that some of you thought, you got right answer, wrong reason. Good for you on a personal level, not a good thing from a competition perspective. So for me, I feel that the question could have been set with better choices of coefficients. That's my opinion. Now, of course, when you say that better choices of this, it means that it should be that 2025 has no solution on top, but let's say 2025 actually has a solution below, and that the actual answer will be different. So that would have been nice, but that is not what has happened. Not that the question has a mistake. Okay. Now, question 7. Drawn without diagrams, right? A few of you were talking about the lack of diagrams. SMO geometry is such that junior usually gives diagrams, senior generally gives diagrams, open it seriously depends. If you look at last year, every question had no diagram. You look at 2 years ago, everything had a diagram. So this year it is the same as last year, but we will not draw any conclusions from that. However, I feel that there is one benefit of no diagrams every time, which is that you get to try to draw the diagram. You get to try to draw the diagram and think about what actually matters. You see, the bisector of angle BAC meets omega. Now, why is this actually something that I underline is that if let's say that you have the bisector just means that it is at the midpoint of the opposite arc. Therefore, I don't need to draw the quadrilateral. Those are useless lines. A, B, C, D are now just going to be 4 points on a circle. That will be less cluttered when drawing the diagram. So the bisector of BAC is going to meet omega at E. So that just means the midpoint of this arc. Let me just adjust it a little so it looks more like the midpoint. I know my circle is not very round, but that's an accurate depiction of many of you who are drawing your own diagram in the SMO. I think they still allow compasses, right? Did they allow compasses? I'm not sure if they allow compasses. Yeah, by right, it is allowed normally, but there's no mention in the official rule, so it just changes every year based on their whims and fancies. Yeah, anyway, ABD, the bisector meets the omega at F, so F is here. Now, what you can say essentially is that this is just more or less like a line of symmetry. That's not exactly true, but more or less. Now anyway, I'll finish drawing first, then I'll comment some more. Right, so AE and BF intersect at P, CF and DE intersect at Q. Yes, and as been mentioned in the chat, yes, this is a kite. It also looks very much like a kite, so again, guessable. Looks like it, right? Now, if it's a kite, then yeah, it would imply that the area is just half times 20 times 11. Now, for the purpose of the round one, I don't really want to talk about proving. You also don't really need to prove it during the SMO, but let me just roughly explain the intuition a bit better by sort of mentioning another thing about these sorts of geometry questions. Now, once you have finished the question, you can think of it almost as if I can redraw it in a different sequence. Okay? So I'll draw a circle first, but I can start with EF. Okay, this is a useful round 2 like perspective, right? I'm not doing a full proof, but a useful round 2 perspective. Now I would think of it as that my A and D are now going to be moving in opposite directions from F. And my B and C are moving in opposite directions from E. And when I say they move, they end up at the same place. Think about, let's say, if you just move the A and D or the B and C, how it will affect things. Right, so which means that I can fix one pair of them and then think about moving B and C along. The idea is that the PQ is going to slide along parallel to this diameter, which is still perpendicular to EF throughout. Okay, that's as far as I want to go. So for a lot of these questions, I'm going to just do proof sketches. The reason why I want to talk about proof sketches rather than proofs is that for a lot of these questions, if it were in round 2, we would do a very different thing. So I'll just declare what's going on and give you an intuition for why. And for those of you that mentioned special case, yes, it makes perfect sense to just assume that this is a special case where EF is the diameter. Special cases are a very important way to get round 1 marks because there is no time to do everything properly. Okay, so I will just move aside from this first. Feel free to discuss in the chat this as well as a few other things that I'm going to just mildly hand wave along the way. Okay. Question 8 is a question that's appeared in the 2017 SMO Open. It has also appeared in a fairly recent SMO Junior with a different set of numbers. The SMO has this funny habit of writing solutions in a different manner depending which section it comes from. So when they write it here, they are going to say something funny like, oh, this is just the magnitude of the vector x1, and this is the magnitude of the vector 4 minus x2. And then by the triangle inequality, this is going to be larger than if you added the two vectors together. This is almost certainly what will appear in the SMO book. A few months from now, you can correct me. But they will write something like this and say that therefore the minimum is 5 when these two are in a straight line. This is the triangle inequality. If you are not from, if you're not in JC yet and you're not familiar with vectors, this has nothing to do with vectors like the special properties of vectors. All you need to do is just Pythagoras and say the same thing. Just draw x and 1. Okay, I shouldn't make them look collinear. I'm trying to mention the triangle inequality. Let me not make them look collinear, okay? No, they do not really look like 1 and 2. Ah well, just to make sure no one's confused. 1, 2, x, 4 minus x. The length of the first one is this. The length of the second one is this. And x is actually something that you can slide around. So the minimum value would occur when this is a straight line, and you can just take this point and move it up to here. That would allow you to get the giant right-angled triangle with sides 3, 4 and 5. Our favorite 3, 4, 5 triangle. Okay, question 9. This one is a repeated idea from the SMO Open, I think either 2021 or 2022. You notice how many times I've said this is a repeated idea already, and I'm going to continue to say it quite a few more times. The fact that I keep saying this is a repeated idea, this is a repeated idea, is another reason why the questions feel easy to some participants. Familiarity with questions makes them easy, not because the person is smarter than you, but because they have seen them before. Okay, 2022, thank you. Yeah, this is not easy the first time, but it is fairly easy. Like if you have seen it before, it is exactly the same. From the perspective of math in most higher levels, it is easier to work with infinitely long than very long. Now, 4 of these square roots is like sort of a very long expression. We prefer it to be infinitely long, just like your geometric progression, right? Many of you know the geometric series sum is a over 1 minus r, but when it is n terms, you forget what exactly the power is in the 1 minus r to the n or n plus 1 or n minus 1. So that's why when we are doing a question like this, it makes sense that you kind of just feed this back in over and over again. So A is itself. Itself is this giant thing. So you can just continue again. And you can see that I do this indefinitely. The reason why infinitely works very well is because when it is infinite, there's no such thing as infinity plus 1 or infinity minus 1. It's just this is the same as this. It's still 8. So you can write it as square root of 4 plus a equals to 8. I feel like I get something like this for my junior mock paper actually as well for this year. So you square it. Now, since they asked you for 2a minus 1 squared, 2a minus 1 squared is 4a squared minus 4a plus 1. So I just substitute in a squared is the a plus 4. And that would give me 17. Now, an intuitive idea that I also mentioned for the, I think when it appeared in 2022, how I suggested that you could handle it if you do not really do this, like extend it indefinitely, is to sort of just say that, consider the fact that this is the function root 4 plus x, and what we are saying is that f of a equals to 8. This is basically what it is saying. And so if your value is any bigger, since your f is an increasing function, then your f of a is going to be even bigger, and so on, such that you are going to end up, definitely this is going to be bigger. And likewise the other way as well. So this is not just for square roots. Now for square roots, maybe this is a little bit more obvious. If I had some other sort of function that you are iterating, you can use this kind of argument as long as it is an increasing or decreasing function. Right? It would suggest to you that f of a equals to 8. So this is something that you can kind of understand intuitively without like explicitly writing all the square roots. Okay, we do question 10 and then we'll take our first intermission. It doesn't actually take as long, right? So I spent 45 minutes, but that's because I did weird stuff like mentioning 2 different methods for some questions and 3 different methods for some other questions. I'll do that one more time here. Calculus or AMGM? Now we all understand what the question is saying. I assume that you know how a graph looks. The minus root 60 and root 60 is actually not even important. I just wrote it there by like almost instinct. This is 60. You want to put in a rectangle with sides parallel to the horizontal and vertical axis. If anyone wants to ask me, what about if you didn't say parallel to the horizontal and vertical axis? The answer is I'm not sure whether this will be the largest. I really do not know. I think that may be a very hard question. But if it's like that, the good thing is that this is symmetric. So you can just let this point itself be x 60 minus x squared, negative x 60 minus x squared. And so therefore this is 2x, this is 60 minus x squared, and you want to maximize the value of 2x, 60 minus x squared. Which I shall just expand into this form. Option number 1, if I call the area this, is to differentiate again. Now in the SMO open, the differentiation thing, integration, is something that there will be 1 or 2 explicit questions on it, right? Later when we get to question, I think 13, you will see that. There will be an explicit question on calculus, but there will also be some implicit questions where you could use calculus ideas, such as what I showed in question 2 just now. Here, if you just differentiate it, so why did I write 8? 6, sorry. 2 times 3 is 6. Differentiate, the critical point would come when this is 0, and x will be equal to square root 20. I don't want to write minus, I assume that I'm only looking on the positive side. It is fairly easy to also see that this is going to be a maximum because this cannot possibly be a local minimum. The local minimum happens at the endpoints when you have got flat or vertical strip. So this should be correct. I can just put it in to check what A is. Okay, let's put 2 root 5. Okay, and so 160 root 5 is the answer. Sorry, no, it's not the answer, it's the area. K is 160. That's the calculus approach. The AMGM approach. I don't like K root 5, so I don't want to put a root 5 in my working. I would just write that. Suppose this is, I just throw away the 2 also. Right? Unnecessary constants are not nice for AMGM. Suppose x times 60 minus x squared is going to be less than or equal to some constant c. Then I move this over. And so I say that x cubed plus c, I know that if I want to make it look like 60x, I can split the c into half. So I guess still equal first. And so I should equate this to 60 and then it would give me the result that c is 80 root 5. Okay. And then the answer will be times 2 over there. So this is how you would AMGM it, because the idea is that for many of these questions, the calculus approach is going to involve more ingenuity. So if you're doing this, let's say as a year 2 or year 3, you had a chance, but it is definitely a bit more difficult. Okay, this is not the only way you can do AMGM. Some of you might share some other ways of doing AMGM, but if you are familiar with calculus, that would definitely be the way to go. Alright, so we'll take our first break here at question 10. Take 5 minutes break. When we're back around at 5 p.m, we will carry on with the middle section. can continue now. Sort of. Shout out to everyone who is following from the SMO camp. I don't know what your camp schedule says you're supposed to do at 5 p.m. If you are following from the SMO camp, please don't get into any trouble. But if you are on break, then I'm sure you do not need that much help with the questions thus far, but there are some interesting ones at the back. Yeah, for this SMO open paper, what happens is that there are significant number of questions you're going to see where after that you think, actually why didn't I solve that? But because everyone's going to kind of think that, so unless you had an especially large number of them where you are like, why didn't I solve that? Like there will be always a couple where you, or even slightly more than a couple where you wonder, why didn't I solve that? As I said in the earlier part of the video, you don't really want to think that they're all hard, and question 11 is an example of that. Now, my first thought when I see question 11 is it's some estimation question. Right? That's my first thought. My first thought is that it is some estimation question with floor x to the power of 5 being not too big. Right? Because if, let's say, for example, if x is more than or equals to 2, then x to the 5 will be more than 32, floor will still be more than 32, but so will x to the 5 itself, and then your x to the 5 is going to be really, really big. Then I thought, okay, so that means that x is going to be something between 1 and 2. But then I realized that that's not going to do very much. If you were to do something like, let's say x, floor x is 1, that doesn't really help me to know what floor x to the 5 is. That doesn't help me to know what x to the power of 5 is. And so what happens is this. If you have got the normal method, which is that this is some approximation thing since they asked for floor, doesn't work, you go back and look at the equation and ask, is there something else nice that I could do? Now this is x to the 5. So my thought was that, you know what? Let's make the bottom the same as the top so that I can kind of substitute it away. So this is what I did. X to the 5 to the x to the 5. It's just going to be 100 to the power of 5, which is 10 to the power of 10, and then I went, oh, so that means x to the 5 is 10. And then I immediately felt a bit of sympathy for everyone that I'm sure would not have noticed this. I did say everyone did not notice this. For everyone who did not notice this, of which there are certainly a few. So, again, SMO open, do not assume it is difficult. It is fine, sometimes. And you should go in with the assumption first for each question. If you can't find a simple method, then you move on. But do not assume that there is no simple method. Question 12. Let a, b, c, d, e be distinct integers with a plus b plus c plus d plus e equals to 9 if m is an integer such that this. Now, to be honest, my first thought was some sort of Vieta thing, right? Actually, my first thought was that x to the, like, x minus a, x minus b, x minus c. This is my first thought because that is a trick that I have employed quite often. As a root x equals to m, then I thought that you can expand this and say this is x to the 5 minus 9x to the 4 something, and then I realized quickly that, yeah, but I don't know anything else, so this is definitely not a good idea. And then after I saw the word integer. The thing about integer is that it changes your approach entirely, and for the SMO open this year, if we were looking at the front part, there are only, like, apart from the question 6, everything else has not mentioned integer yet. This is the first actual, like, appearance of them being integers. So since they are integers, you just factorize 2009, that's all. I took my first time taking the SMO open, when I was in year 1 was in 2009. And so I personally have very clear recollections of the factorization of 2009, and the fact that many people thought that it was prime if they didn't go in having already known the factorization. So of course 7 squared times 41, if you are like, that's not enough factors to go around, then you've forgotten 2 things. First of all, you've forgotten that 1 is allowed, right? You can use 1. The second thing you've forgotten is minus is also allowed. So the way that you can distribute it, and indeed the only way that you can distribute them, is some permutation of 1 minus 1, 7 minus 7, and 41. Just since it's a permutation, the best thing I can do is just to add all of them. So 5m minus a plus b plus c plus d plus e, the pairs of them cancel, you get 41, this is 9, so m equals to 10. Another 10. And now I feel old. You know, it's so weird, right? Then after that, when you guys basically sometimes, as my students tell me that, oh, you did some very old SMO paper. It's like, what very old SMO paper? Like 2015. I'm like, oh my gosh, I graduated by then. Now I feel very old. But you should try some of those old papers, because in truth they do recycle ideas from old papers. This was an idea that actually is similar to some 2011 question as well. Don't ask me why I know all of this, but it's just that a lot of these are really familiar to me and possibly to some of your friends as well. That's why they say it's so easy, and you may not have felt that way. Okay, question 13. Fractional part. There are many times where fractional part will make the question very difficult, and this is not one of them. Fractional part is just going to be the same. The graph of the fractional part just goes like this. And if they do not look parallel to each other, that's my fault. This is what happens. Now, of course, this is the graph of the fractional part, but my point is that this is periodic. It's period 1. By definition, that means that you've just got 9 cycles of 1 period. And in the first period from 0 to 1, this is just the same as x itself. Okay, so super straightforward. You're noticing that some of the floor functions, like in question 11 and now question 13, they're flooring stuff that are not actually non-integer. Yeah, the floor functions do not necessarily mean that they are non-integer. If you saw the SMO senior paper, they asked a lot of these things in a slightly different way, right? A lot of the smallest positive integers, the largest positive integer such that it's greater than this, such that it's smaller than this. The way that it's asked every time is a bit different. Okay, so just do not read too much into these. If you got a non-integer answer, you know you're wrong. But if you got something that's an integer answer and you're sure it's correct, then just ignore their flaw. Don't get intimidated by unnecessary signs like absolute values of positive numbers or flaws of integers. Okay. 14 is still not difficult as an algebra task, especially since you kind of have a check built in. The reason why it is not hard is that although I can solve it normally by splitting into cases, I don't really even need to, because A, B, and C are going to be the equality cases, right? These two are continuous functions. So like you can imagine that they look something like this, not this, and they look something like that probably, because it's just an absolute value means that the bottom part got flipped upwards. Now, wherever it is that they cross between being bigger or smaller than each other are the places where they intersect. So you just solve the equality case if you want to get A, B, and C. Now, the equality case could either be this, or it could be with a negation. So again, not hard. So this one would give you x is 2/7, one solution. So 2x squared minus 3x minus 14 equals to 0. This thing can be factorized. Can't be factorized, right? Yeah, okay. Yeah, it can be factorized into x is 7/2 or minus 2. It's like for a while I looked at the number wrongly. So this is your values. Remember that you are first absolute value all of these and then multiply by 14. And then the floor is redundant again. Easier than senior, yes. If you look at the open, the general trend for the last 5-6 years is that because open is covering a range, right? So senior is very targeted at the topics they want. Open covers a range. So open, the hardest open questions I can guarantee you are actually hard. But the easiest open questions can be quite approachable compared to even like some of the senior questions. So it is true, your sentiment is correct that open can feel easier than senior. This year it does feel more noticeable because senior increased in difficulty and open has more approachable questions, but it is still a generally true statement that the SMO open has some approachable questions that the SMO senior may not have as many of. Okay. Question 15. I'm sure some of you have guessed x equals to y equals to 1, right? Just admit it, and I would do the same also, right? Surely some of you have guessed that, right? I cannot imagine that nobody guessed x equals to y equals to 1. Let me just explain one way that I can do it that I think is interesting. This sorts of algebra questions, there are always a bunch of possible ways to do it. I'll just explain 2 ways of doing it. Method 1, I am always a fan of doing a nice trigo sum. So I'm going to just let x equals to root 2 sine alpha, y equals to root 2 sine beta. Now I like this because of the fact that this is the easiest way to clear square roots, number 1, and number 2, I am comfortable with trigo, and none of you have seen any trigo in this whole paper, right? So I'm sure that there's no trigo here. It's a huge bonus for everybody. Let me just insert a little bit of trigo into this tree. So the substitution will give you, now you can assume without log that your x and y are positive, so assume your alpha beta in the first quadrant just for convenience so that I don't have to deal with any weird sign issues. So this would literally give you sine alpha cosine beta plus sine beta cosine alpha equals to 1. And so this means that alpha and beta are complementary angles, and if they're complementary angles, it just means that you can switch this over to cosine alpha, and so therefore x squared plus y squared equals to 2. This is option number 1. for a proper solution. Right? Option number 0 is to guess that they are both 1. Method 2 is that this is the equality case of Cauchy-Schwarz. Every time when I do a trigo substitution, I always suspect that there probably was a Cauchy-Schwarz way to do it. Now remember with Cauchy-Schwarz that the order can switch around. So I'm going to just do that explicitly here. And so equality holds because they're both 4. Now the trouble with equality holds is that what is the equality case for Cauchy-Schwarz? And the answer is that the equality case of Cauchy-Schwarz is that the stuff that you put in here are in the same ratio. But if you square both of this, you add 1 to both of them, and then you cross multiply, you will end up with the same conclusion of x squared plus y squared equals to 2. If you're going to say AMGM, we're going to say some other stuff. Basically, there are lots of things that can work. So I'm just mentioning Cauchy-Schwarz because very often when there is a trig substitution approach, there's also a Cauchy-Schwarz approach, but AMGM could also work, as well as yeah, some other methods definitely work as well. Okay. Now, question 16. Finally, this is one of them where it is not so straightforward to just guess. The question is about dividing a polygon into regions, and when we are dividing a polygon into regions, I will try to go with the same general mindset as I've shared earlier, which is that let's do some let's do some small cases and find a pattern. Possibly find a pattern. It won't be too long before some of you mention in the comments that you could not find a pattern. Well, I will address that in a moment. 11, right? Now once I reach n equals to 6, I'm a little bit irritated by the thought of counting wrongly. So one option is to draw a really big hexagon to make sure that I do not count wrongly, but that will only take me so far. The other option is that as I'm drawing, let's see if there's a way to count as I draw. Now I take this one here, let's say I start from this point. So I've got one region, now I draw this, I have added one region. I draw this, I add another region. I draw this, I add another region. Okay, so now I've connected that first point to everything. Now I draw this one here, I cut 4 regions. I draw this one, I cut 3 regions. I draw this here, I cut 2 regions. Then I come here, I draw this. Now I draw this to try to prevent them from being concurrent. So now I've cut 1, 2, 3, 4, 5 regions. So now I cut 3 regions. Then finally one last one here. And I draw it, I cut 1, 2, 3, 4 regions. Okay, so altogether there are 25. Does anyone see a pattern in 1, 4, 11, 25? I do not see a pattern in 1, 4, 11, 25. If you see a pattern, then you are definitely better off than me. Now, a fun fact about this is that this is actually a famous trick question that has been restated. The famous trick question has to do with drawing a circle around it. If you draw a circle around it and ask for the number of regions of that, then this will have 4 regions, this will have 8 regions, this has 16 regions. But now if you actually did this here, you will see that there are 31 regions. So it's the famous trick question of if I just divide a circle using n points, it looks like powers of 2, but it is not. Now this is the same question except that they didn't draw the circle. So let's now talk about how you do this. Right? So how do you actually count it properly? Because in this particular case, the pattern is not something you can observe, and it's quite hard to guess. And you can't really draw enough lines to get to 2,500 regions clearly. The first thing is that I have basically outlined the approach to an extent. Now I've outlined the approach to an extent, which is that each time when you draw a diagonal, you can see how many regions it intersects. Right, so almost like some sort of algo, right? For each diagonal. So just number of regions intersected, just increment it, plus equal to this. Now if you do that, you realize that, well, I mean, how am I supposed to know how many regions are going to be intersected? So I need to change that to some more meaningful way. And I realized that, well, the number of regions intersected means that every time I go into a new region, I crossed another line. So for example, when I drew this final yellow line, it went through these 3 points, and those 3 points meant that I was in 4 regions. So this is actually the number of diagonals intersected plus 1. In other words, each diagonal contributes 1 plus the number of diagonals it intersects. And therefore your answer should be 1, right? So not the answer, the number of regions. You start with 1 region when you draw the boundary, and then after that the number of diagonals, because each of them contributes 1 at least, plus the number of intersections of diagonals. So, number of diagonals and the number of intersections of diagonals. The number of diagonals is going to be n choose 2 minus n, because the sides don't count. The number of intersections of diagonals comes from, we don't count the common points, right? Those are not intersections. The intersections are like all these guys in the middle. So how I count that is to say that every 4 points on my polygon contribute exactly one way of forming two diagonals that intersect. So it's n choose 4. And so my provisional formula is 1 plus n choose 2 plus n choose 4 minus n, which I hope is correct. Unless, of course, I have missed anything off by 1. So this is a good time to just substitute in like n equals to 6 to just check. It's a good practice every time for round 2 as well. When you come up with a general statement, just sub in a small case that you have already worked out in your experimentation, just to make sure that you haven't messed up. So this is 25, 25, okay. So I'm quite confident that's okay. Now obviously you are not able to solve a quartic properly, but we know that n is an integer. And so what I can do is just to play a higher or lower game to figure out when is this equal to 2500. You just play a higher or lower game, like a binary search, to get to 2500. For example, if I guess that I need something like, you know what, maybe I should also talk about the initial guess. This is on the order of n to the 4 over 24. And this is the dominant term. And so if I wanted to do a higher or lower guessing game, my starting point should be where n to the power of 4 is roughly around 60,000. And so n equals to something slightly less than 20. Should be a good idea, right? 20 to the power of, actually no, it's quite a bit less than 20, but well, somewhere in between 10 and 20. Depending on how fortunate you are or unfortunate you will substitute in some values, and eventually you're going to find that n equals to 17 works. You're not very interested to see me calculate this for a bunch of values from n equals to 15 to 20, so I will leave that to you. Yeah, it's true that the left hand side is quite factorizable. So if you wrote out everything, there is a factor of n minus 1, which you can use to help you out a bit. You can, however, say that n can't be too big, so I'm a bit partial to just substituting and trying out. Okay, so that is for question 16. That is not so easy. So this middle section here, there are just a handful of not so easy questions. This is one of them. Another one is potentially question 17 that is not so straightforward. Just zoom a bit. No, I don't know why it zoomed out just now. N equals to, n plus 2 squared plus n squared is divisible by 2029. Option number 1 is of course that you can try to guess an initial value of n and just hope that that's the only value that works mod 2029. That would have been wrong, unfortunately. So step 1 is that this is prime. Nobody, of course, will tell you that you must memorize the factorizations of all the year numbers all the way to 2029. But yeah, 2029 is prime. That's something that we can verify a bit grudgingly and slowly, but it is prime. And so I have to just handle 2029 directly. Now, n plus 2 squared plus n minus 2 squared, I just expand it first. This is 2n squared plus 4n plus 4. Now I can just divide by 2 because that doesn't have anything to do with divisible by 2029. So I get n squared plus 2n plus 2 which is n plus 1 squared plus 1. Now that's a little bit better. So the question now reduces to this. N plus 1 squared plus 1 can you get it to be a multiple of 2029? Now essentially, minus 2029 to 2029, this means minus 2029 to negative 1 and 1 to 2029 with a 0 in between. That kind of doesn't matter. This is just two sets of residues. Mod 2029, which means that I just need to find the number of times where n plus 1 squared is congruent to negative 1. N plus 1 squared is congruent to negative 1. It's just a square is congruent to negative 1. So if I want this to be congruent to this mod 2029, I just call this thing m. And the question is, how many solutions m squared congruent to negative 1 mod 2029? And then multiply that by 2. That's the question. So how many solutions for m squared is congruent to negative 1 mod 2029? Well, I can at least answer one thing, which is that suppose that m squared and n squared are both negative 1 mod 2029. Let's not call n, k. Let's use a different variable name. Suppose that two of them are the same, then it implies that m squared minus k squared is 0 mod 2029, and this factors into m minus k, m plus k. I'm talking about two different solutions, m and k, so the only way that you can get two solutions is if m is congruent, so m plus k is congruent to 0, which means m is congruent to minus k mod 2029. So at most 2, right? At most one pair. Alright, so at most one pair. If let's say you had no idea, this is a good time to guess that the answer is hopefully there is somewhere a solution. I'm a bit lazy or I'm a bit out of time to find it. I hope there is a value that is negative 1 mod 2029, and you guess that there are two of those, so your answer is 4. Right? Remember I said times 2 at the end because there are two sets of residues. If you guess this, you would be correct. Now, technically, the fact that m squared congruent to negative 1 mod 2029, this is something that is one of the few high-powered things that you need to know. This is actually your quadratic residues. This is not a fraction. It's a Legendre symbol. So it means that negative 1 is attainable. And in general, so these quadratic residues, there's a whole theory about it, and I do not want to talk about it here, but in general, x squared is congruent to negative 1 mod n, sorry, mod p is attainable if and only if p is 1 mod 4 or 2, I guess. So, and if it's attainable, there will only be 2. So this confirms that the answer is really 4. It's one of the few high-powered things in this paper. Alright, let's do one more simple one relatively before we move on. We will do 18. Now this is simple enough because it seems that the functional equation questions seem to ran from senior to open, and all the tricks seems to have ran from open to senior. So the question profile has changed a bit. It will change again. I do not read too much into any of these. But this is simple because it is a classic case of your functional equations, the two arguments can swap. Now, a functional equation, you must understand it as an identity that is a private, one question only identity. There is a one question temporary identity that outside of the scope of this question has no meaning. It's sort of like if you create local variables in programming or a local function in your programming, then you can use that function in that scope. So you can substitute anything you want. You can replace x by minus x, by 2 minus x, by 2, by 5, by 34. Why this works well is that, of course, it will swap around. 2 minus x is going to be x. Okay, expand, and these are equal. These are equal, meaning that you just have got a simultaneous equation to solve for fx. I eliminate the f2 minus x. And this is the function. So that's step 1. And then it seems that they hadn't had enough of making you do a sum of squares, so they make you do a sum of squares again. I do not agree with like putting in a question like that just to test you something like, so the functional equation thing gets tested again in question 20, and then the summation of this thing has already been tested in question 1. So it's a little bit redundant. But the SMO Open has done this last year as well. Like pairs of questions using the extended sign rule, for example. A pair of questions using the same sort of series summation. So it's a doubly painful lesson if you did not know how to sum this, but hopefully now you know. Pull out the 1/3. So sum of n squared, we have seen just now. Sum of n, and then sum of 12. It's a bit annoying, so I'm just going to put down the numerical value at the end of this, and we can go to our second break. We will come back and look at the last 7 questions in the final segment. So for those of you who are just joining in, welcome. The video will remain up as usual, so you can just watch the earlier parts back, whichever you have missed, for just addressing the cutoffs one more time. I think that this paper is one where there are a significant number of questions that are welcoming, doable, or familiar, and so yes, you can call it easier if your target is to get something in the vicinity of 10-ish marks. It is much easier to get 10 than in some of the previous papers. So as I mentioned, my guesses would be something like 14, 12, 10, 8 is my initial ballpark figure. It is entirely possible for some of these to be up or down by a mark or two, because the number of qualifiers and the number of awards are discretionary. Another thing is, of course, that for the top students, the fact that there are multiple easy questions is also going to mean that they have enough time to do more of the harder questions. It's not that the harder questions aren't hard, you just now have enough time, and then that would also boost the top end of scores, right? So some of you, I guess, in your own schools, you may know of people who are getting full marks-ish scores. That would be because of the fact that essentially you can clear 15 questions in an hour. That is a huge difference from clearing 15 questions in 2 hours and then trying the rest. Alright, so let us finish off with the final segment, starting with question 19. Pretty interesting question. Not hard if you have learned some number theory, very hard if you have not learned this number theory idea, which I'm about to mention. Now the question asks you for the largest. So if you really don't know, of course, trying something like p equals to 2, p equals to 3, all this is fine. The answer turns out to be 761, right? Which, if you have heard, you're a bit mystified, possibly, by how does anyone actually know 761? That's really weird. How does anyone think specifically of the number 761? The answer is they don't, right? Nobody would think specifically of the number 761. What they would be thinking of is that if my p is big, just more than 7, then what would be true is that a to the p minus 1 is congruent to 1 mod p by your Fermat's little theorem. So your Fermat's little theorem, as long as a is not a multiple of p, which if p is more than 7, none of these are multiples of p. The other thing that this would imply, a to the p minus 2 is going to be congruent to 1 over p. This is your modulo inverse. So 1 over a, not 1 over p. So this is the inverse of a. If you know modulo inverses, then you would know that we are allowed to actually just then say that S of p is congruent to 1 over 1 plus 1 over 2 until 1 over 8, and literally add up the fractions. Literally add up, so I should write all the fractions down. This add up to 1, so you've got 2, you've got 3/8, you've got a 1/5 and 1/7, so then those you just add. If you add them up, you will get the 761 over 280, which means that in order for it to be divisible by p, p must be a factor of 761. But 761 is prime. So it is 761. If you did not know modulo inverses, you are still not yet doomed. You need to know Fermat's little theorem. But if you did not know modulo inverses, what you could have done is that if this is supposed to be a multiple of P, and again assuming that P is large enough, you can multiply in the LCM of 1 to 8, which is 280. Multiply in, assuming that P is more than 7, again it is irrelevant. And what you have done is just to donate an extra factor of 1 to 8 to anyone that needs it. And so you'll end up with, for example, the first one is 280, the second one, you borrow a 2 and then the rest stays behind. What 280, what am I talking about? No, the 240. 280 or 240. It cancels off there, yes, correct. So it cancels off there, but the LCM of 1 to 8 is the LCM of 1 to 8. 420, 840. Sorry. Apologize for numerical confusions. Three, 4, 5, 6, 7, 8, and then you just add this up, and I believe you would get 2283, which is 3 times 761. So that would give you back the same answer as well if you knew Fermat's little theorem but did not know about modulo inverses. So this question is not so easy, but it is reasonable for open. If this appeared in senior, more of you will be even angrier than you already were to begin with. Oops, sorry, let me get back. Question 20 is relatively easy again. It's relatively easy again because this is the second instance of functions that will just loop around. Some of you have asked me before, how do you know that they will loop around? The truth is that there are not many ways to make things loop around, so almost all questions like that are set roughly to look the same. So just by looking at the last few years, every time when they loop around, it's always this thing: x and 1 minus x, x and 1 over x, x and 1 over 1 minus x. Like, these are not exclusively the only ones, but they tend to be just these few things. So don't worry too much, I'm just pointing out that if you didn't know, now you know. And this could well be what continues to be asked when they want this looping feature. But the question is asking me for 10 instead of earlier on add from 1 to 34. So I do not need to just substitute in terms of x. I can literally put in values. That will make my life a bit easier. So you put in this, you get 10 and minus 1 over 9. Then you put in minus 1 over 9. You end up with 9 over 10. And then you put in 9 over 10 again. It loops around, very nice development. You want to find f of 10. You just take the first plus the third minus the second, and you get 2f10 equals to this thing. I don't need to simplify, I just multiply it by 90, and for like the fourth time today, the floor function is redundant. If you want to find out what the function is, then you can check by looping that 1 over 1 minus x and seeing what you get. And then x minus 1 over x will be the third thing. You can solve it. Not very important here. Question 21 is actually not an easy question to solve properly. Now I looked at this and then I was a little bit surprised, right? Because I was like, this doesn't seem like a question that is very SMO open-like. And then of course I did a little bit of searching and I realized that this question is a Putnam question. It's from 2008. Putnam, as you may know, is an undergrad Olympiad. It doesn't require anything fancy. It's just that you wouldn't be very unlikely to come up with the proof in competition time. These Putnam questions are 4 hours, 6 questions. Was it 5 hours? I suddenly forgot. Anyway, it's not difficult to guess that the answer is potentially 2. Right? Because this just means you have got a circle with irrational center. At least one of its coordinates is irrational. And then you want to find rational points on it. Now that is not hard, right? So for example, if I just took this point here as the center of the circle, like root 3, 0 or something, it's possible to just have a circle that passes through 0 and minus 0, 1 and 0 minus 1, for example, right? This is not very hard to come out with an example with 2 points. It is 2. Now the idea is that this is a round 2 style question. Whenever in round 2 they ask you for a maximum or a minimum, you will try to construct first or bound first and then do the other. Whichever one is clearer, you do first. So this one is that I can construct 2. I can't figure out how to construct 3. So yes, indeed, as some of you have mentioned, the proof is that if there are 3 rational points on a circle, then the sequence in which you would find the circumcenter is as follows, right? Midpoints are rational, gradients are rational between any 2 of them, and so therefore the perpendicular bisectors are rational, and therefore their intersection, which is the circumcenter, is rational. So you can just justify like sequentially that all of these are rational. You do not really need to write out anything even in round 2. You can just say that by this sequence of steps, the intersection will be rational, and of course rational meaning both coordinates are rational. So this confirms that the answer is indeed 2. It's kind of a not so difficult to prove question, admittedly, if you have sufficient time. I'm just saying that in round 1, very possible that you are not so inclined, and as I have highlighted earlier, you should not spend too much time trying to prove everything that you are asserting. Question 22. I feel like I have mentioned at some time that 24 through 3 is equal to 2024. This is going to be important, but if you have heard this and are aware of this before taking the SMO, it would save you a little smidgen of calculation time on this one. Now, when I read this question, my first thought was actually, the 3 points, is it exactly? Or is it at least? I mean, you've heard of the trick question of how many months have 30 days in a year. And that's because when they ask it like that, 11 months have 30 days. It's just that there are 4 months with exactly 30 days. So that is an important distinction. But the fact that they did not mention that here, usually it means that we forgot to mention it as a question setter because it doesn't matter. Right, so for instance, whenever they say from here to there, they forgot to say inclusive or not inclusive, usually means the boundaries don't matter. Like, the boundaries don't matter, so why did they have to tell you inclusive or exclusive? They don't work anyway, or they all work anyway. So that is my suggestion when it comes to these sorts of slightly ambiguous sounding questions. It probably doesn't matter. Now in this case it doesn't matter because you want to have few blue points such that each red point is the center of a circle passing through 3 blue points. We just talked about circumcenters like 1 minute ago. Any 3 points in general, but any 3 blue points, you get a unique circumcenter. As long as you make sure that no 4 of them are concyclic, which you can certainly do. Right, so ensure that no 4 blue points are concyclic, just like you can ensure no 3 points are collinear, and then now there will be no more question mark on this. You do get a unique circumcenter. So I want each red point to be the center of a circle passing through 3 blue points. That means that if there are n blue points, then it gives me n choose 3 circumcenters. And so n choose 3 places that I can put the red points. What I need is that with n blue points, I get at most n choose 3 red points, and so therefore n plus n choose 3 has to be at least 24. Now, it's useful if you now know that 24 choose 3 is 24 because n equals to 24 would work, but for n equals to 23, in my senior mock paper I miscounted, right? So I shared that I miscounted and accidentally gave a question that was supposed to be 2024 as the answer, but instead it was 23 choose 3 is 1771. So because of that accident, I kind of remembered the answer for 23 choose 3 being 1771. So this doesn't work, and therefore n equals to 24 actually works. Question 23 is quite a simple problem for those who are experienced with inequalities. It's also a good teaching example. So like as a teacher, I'll be very happy to include this in future lessons on redacted inequality. I will say in a few seconds time. Someone's going to write a spoiler in the chat anyway. The thing that you want to understand is look for the descriptive relationship between what you're given and what you're trying to find. I mean, descriptive as in you don't need to describe it algebraically, just literally, oh, they're the same thing except the square has disappeared. Right? That's the level of description that I'm referring to, like just very vague. Now, why that is important is that if there is an overall correspondence, like, oh, this one went from a whole bunch of things added together to a whole bunch of things being multiplied together, that's like a big global thing, then AMGM is your first go-to. But this is a term by term thing, and so therefore, as a term by term thing, Cauchy-Schwarz is going to be our idea. Now, you would like to use Cauchy-Schwarz because Cauchy-Schwarz is what I call like term by term AMGM. Pair by pair AMGM is a maybe more accurate way of describing it. Right. This is the geometric mean of those two, this geometric mean of those two, and so on. So Cauchy-Schwarz is like a more customizable AMGM in a way. And so Cauchy-Schwarz is something that you set up in a DIY fashion by saying that, okay, x1 squared over x1 squared plus 1 and then I want to now get to x1 over x1 squared plus 1. So I ask, okay, the first thing, these two, I want the geometric mean to be this guy. How will I make that happen? That means that the product of those two should be the square of this. And that will happen if you put in 1 down here. You actually just do this process once because the rest of it is all the same, just with different variable names. So you just carry on. So this is your application of Cauchy-Schwarz. Very direct. And the nice thing is that you realize that these two here, this is the one that we were given, 2025, but these two sum up to 2026 once. So this is 1. And the maximum, therefore, is just the square root of 2025, which is 45. Talked about equality case of Cauchy-Schwarz earlier on. So let's reiterate, the equality case of Cauchy-Schwarz is they're all in the same ratio. And if they're all in the same ratio, the ratios are all x1 squared, x2 squared, and so on. So that turns out to be they're all the same. Now this is an important sort of teaching point. Just guess that they're all equal if you're stuck on inequality questions as well. Like seriously, just guess that they're all equal means that x1 squared over x1 squared plus 1 is equal to 2025 over 2026. This is like the world's easiest equation to solve, right? It just means x1 equals to 45. And so you look at this and you say that, okay, they're all equal to 45, means that each of this is 45 over 2026. You have got 2026 of them, so therefore that will give me 45. And this is just way too nice to be a coincidence. So you should do that. And this is one of the things about inequalities. It's very hard to set round 1 inequality questions because they're either too hard or they are very easy to guess. There are ways to make them less easy to guess, but thus far the SMO has not made serious efforts to prevent guessing many of these questions. So just make use of the guessability for now. Question 24. It's quite funny, right? There's really been very little combi this year, so the counting has been very minimal. This one's not so bad. Like this open paper, there was the diagonals question, and then arguably question 22 was a pigeonhole, but this is the only true P and C question. Don't count on it continuing. It may or may not. Only if we have a few years of trends, then can we say that combi is disappearing. But this is a fairly nice question in terms of the fact that it just highlights a couple of common ideas. Now both rules have to do with the M's and the T's. The other letters, there are two A's, and then there is a C, a E, a H, a I, and an S. Somewhere in one of my Sec 4 classes, I have an entire lesson that consists of questions about arranging the letters of the word mathematics in a row. Some of you who are in my class will remember that. So I was looking at this and I'm like, this looks like it just fits into like part K of my worksheet or something. So great. Why is it just like one of many parts? Because think of it as 11 slots. Once I insert the M's and T's, then you are just going to be left with arranging these. 7 factorial over 2 ways to place the rest, regardless of where you place the M's and T's. So all we need to do is to just focus on how many ways there are to do this. Now, both M's precede both T's. Both M's precede both T's. What does that mean? That means that actually the positions are fixed. What does positions fixed mean? It means I just need to decide on the 4 positions, the 2 on the left and the 2 right positions are not adjacent. So this is the situation. The positions are fixed. The 2 on the left, the 2 on the right are not adjacent. This becomes a partitions question, or stars and bars, balls and boxes. You want the locations of your 2 M's and your 2 T's. There must be at least one between them here, and at least one space between them here. Other than that, because there are 11 letters, there are just 5 more spaces to distribute and 5 zones, which is the same as 5. Okay, so I'm just going to put 5 horizontal lines so that you know what I literally mean. 5 more horizontal lines to insert in, with the 2 that are already forced inside here being sort of there first. So 4 partitions, which are the MMTT effectively, but you can think of it as the partitions are the dots. You arrange this. This is nitrous 4. And so that's it. Your n is just 126 times 7 factorial over 2. Chop off 6 factorial. And you're left with 126 times 7 over 2, which is 441. This is going to be the shortest open stream there has been, right? So this is one of the rare times where open has not really been time limited, it's been more problem limited, because very often for open the algebras take really long, and so even though you could solve more given time, you ran out of time. This one's one of those cases where the algebras are quite easy in terms of length of time needed. So if you know what to do, they're fast, and for the Olympiad style questions, if you know what to do, they're also fast. So not time limited for once. Okay, so let's not delay and carry on with our last question. The first thing about the last question is that you are really annoyed by the fact that there is no diagram, because it sounds really complicated. The second thing about the last question is that you do not draw everything whenever they ask you to do 3 things. The semicolon is sort of almost like a hint. when we do in math, when we write semicolons, right, there are two possibilities. One is that the person who is writing it does not understand punctuation, but the second more likely possibility is that we are just saying that, and likewise this, and likewise this. Meaning that it is just symmetrically defined, and so therefore there is not a lot of purpose to writing everything in full, or drawing everything in full either. So I am only going to just do the d prime thing, and I trust that the rest should be okay. Alright, so I'm going to draw the diagram in that manner. Now here is three AB, BC and CA, three lengths that are almost equal to each other. This is the very famous 13, 14, 15 triangle. Just for trivia, the 13, 14, 15 triangle is nice. Because it just is your two other small famous triangles glued together. And so this is a hint that it's a nice triangle. It's nice because the area is nice, and therefore you can do stuff with it if you need. It's also nice because the angles, the sines, cosines and tangents are nice. Now I'm going to in fact just squeeze it down to, I should squeeze it down to 13, 14 and 15 I think. There is no point in doing something bigger than that because I can just scale it back up by 4 later anyway. So I am probably going to just use 13, 14 and 15, but for now I'm not going to write anything in, I'll just label the points. And immediately I labeled the point wrongly. Okay, you know what, because I like to work downwards, so since I drew it like that, let's not use the D prime, let's use E prime, right? So this is just for the purpose of making the drawing nicer, I will go downwards. And so I will use the intersection with the circle through A, I and C. You should know your chicken feet theorem. This is a very famous configuration. The circle through A, I and C would be, if you draw this over to here, then these three are equal, and so this is the circumcenter of A, I and C. Your chicken feet theorem, 鸡爪定理 as it's affectionately called over here. And I'm not done yet. I want to extend, but if I want to extend, it's not so bad. It's just going to be like this. I don't need to draw the circle. So I would like to find the length of E prime. For anyone that is of the opinion that this does not look like a chicken feet or even a duck's feet, that's because this is actually not the chicken feet theorem. The chicken feet theorem is that it is the circumcenter of AIC and the X center is point number 4. So I'm going to draw another one here. This is also collinear. So this BI, I'll call this point here just P. And then this I'll call it IB because that's the X center opposite point B. Now, the chicken feet is actually these four. But here they've kind of given you one more thing which makes it no longer look like a chicken feet, whatever, I don't care. It is still good to put all of these in. Why is it good to put all of this in is that you just realize that, assuming you know what the x center is, the x center is the center of the circle, where if you were to draw the tangent like this, then that would be the center. Now this is a horrible drawing, so I am not going to do that, but all I'm going to say is that this thing's actually the x radius, because if you were to draw it here, this is what it's equal to. So we have discovered that dd prime plus EE prime plus FF prime is just the sum of the 3x radii. Now, if you knew the x radius, there is a high likelihood that you also know how it is computed. It is just going to be related to the in radius by a simple expression that says that the area of your triangle is RS. It's also equal to RA times S minus A, RB times S minus B, and RC times S minus C, where S is your semi-perimeter, RA, RB, RC are the 3x radii, and that's great because I already know the area. So using the 13, 14, 15, I can get that first. Right, so scale times 4 later. I've already said the area equals to 84. S is equal to 21. And so this is equal to 21 minus, which is A, which is B, which is C. The scale down A is 14. The scale down B is 15. And the scale down one is 13. And so RA is equal to 12. RB equals to 14. And RC is 10.5. Okay, so this is the scaled down one. You push it back up by 4 times to get your answer, which is 146. Once again, some of you may have tried to do this by just estimation and assuming that this thing here is just equilateral. I do not know how good that would be this time. I did not try that out. But it is always possible for geom questions to just approximate the length out to a special case. If that is the best that you can figure out, you have a chance. Alright, and we are done with 25 questions in slightly under 20 minutes, including a bunch of breaks. So time-wise, this is achievable. Do not be discouraged if everyone around you is saying it's easy and you did not feel that it's easy. Do not feel discouraged if you are hearing that your classmates or even a junior did better than you. I mean, speaking for myself, right, is that there have been plenty of times where I have done better than younger students. And older students, there have also been plenty of times where younger or older students have done better than me. So do not feel discouraged by that. Do not also assume that this is representative of all SMO Open difficulties henceforth, or even SMO Open topic distributions henceforth. If you're watching this in 2025, maybe you will not find this very difficult. We do not know how the questions will look each year. Now, having said that, if there are some specific things from today that you didn't know, now you know, and the fact that you're here is great because SMO is entirely over for round 1. If you're here, it means that you're still interested, and for open, most of you are doing it because you're interested. So don't just check your score. You could have checked your score earlier if you wanted to already, but the fact that you're here means you can absorb some of these ideas, and whether they're useful or not in future, we will see. Alright, so as with the junior and senior one, I will just stick around for a few minutes if you have any other questions. If not, then we are done with the SMO round 1 season. I'm sure some of you will make it into round 2. So all the best for the round 2. Open round 2 is hard, but it is not different from round 1 in the sense that there are easy questions and you want to look for them. Do not assume that every open round 2 question is impossibly hard. I think it's very hard to say the difficulty of round 2 fairly because it feels like there was a refresh, right? So 2020 and 2021, because of COVID, there was no round 2. When it came back, it feels like there was a bit of a refresh, right? Like senior difficulty just skyrocketed, and then open difficulty didn't skyrocket, but it definitely went up a lot in 2022, and then it went back down in 2023. The open round 2 is primarily, you must understand that the SMO open is as follows, right? There are 3 coordinators. There's a coordinator for the junior round 1, senior round 1, open round 1. And then there is a whole committee that does round 2 that are not those 3 people. So round 1 and round 2 are just independent, right? In statistical terms, it's like the difficulty are like 2 independent random variables. And so there is no correlation between round 1 and round 2 because the round 2 problem setters, their priority is to select the national team. The round 1 problem setters is to be for all the 2,000 participants. They are not the same people. They are both part of the Singapore Math Society, but I don't think they even like discuss together at the same time about the relative difficulties. So it could be anything. And we only have 2 recent samples, 2022 and 23, so very hard to say. Otherwise, have a good holiday break, especially for those of you who are in JC. I know that JC holidays are very precious but also very busy. Just please do get a good rest, get a bit of a breather before you carry on with anything, whether it be your Olympiad side or just schoolwork side of things, right? Just as far as possible, even just half a day's break can be really great. So just give yourself a bit of a breather before you carry on with stuff. I'll end the stream here first. If you have any more comments, any more feedback or stuff you notice later, just feel free to comment in the comment section below after the video is uploaded. And then do also look at some of the round 2 questions if you haven't already, especially the whole bunch of you who are clustered around 14, look at some round 2 questions, because you don't need to be able to solve a lot of them, but there's a huge difference between one question and no questions. So that's what I have to say. Thanks everyone. Bye for now, and see you again soon.